Mars. Everything you need to know about the red planet. Mars is one of the most explored bodies in our solar system. Here's why. Mars is the fourth planet from the Sun and has a distinct rusty red appearance and two unusual moons. The red planet is a cold, desert world within our solar system. It has a very thin atmosphere, but the dusty, lifeless, as far as we know it, planet is far from dull. Phenomenal dust storms can grow so large they engulf the entire planet. Temperatures can get so cold that carbon dioxide in the atmosphere condenses directly into snow or frost. And Marsquakes, a Mars version of an earthquake, regularly shake things up. Therefore, it is no surprise that this little red rock continues to intrigue scientists and is one of the most explored bodies in the solar system, according to NASA science. Befitting the red planet's bloody color, the Romans named it after their god of war. In truth, the Romans copied the ancient Greeks, who also named the planet after their god of war, Ares. Other civilizations also typically gave the planet names based on its color. For example, the Egyptians named it Her-Desher, meaning the red one, while ancient Chinese astronomers dubbed it the fire star. Why is Mars called the red planet? The bright rust color Mars is known for is due to iron-rich minerals in its regolith, the loose dust and rock covering its surface. Earth's soil is a kind of regolith, too, albeit one loaded with organic content. According to NASA, the iron minerals oxidize, or rust, causing the soil to look red. Mars Q&A. What type of planet is Mars? Mars is a terrestrial, or rocky, planet. Why is Mars known as the red planet? Mars is known as the red planet because it appears faintly reddish-orange when viewed in the night sky. This reddish color comes from the abundance of iron minerals and dust on the Martian surface. What makes Mars different from Earth? Mars is further from the Sun and smaller than Earth, and at least as far as we know, does not appear to be habitable by life. What do we know about Mars' past, and was it ever like our planet? We've learned a lot about Mars from the past 30 years of lander, rover, and orbiter missions. We have confirmed the existence of past water on the Martian surface, that Mars was once a habitable planet, and that it once had a thicker atmosphere than it does today. What have we learned about Mars over the past decade thanks to missions like Curiosity, InSight, and Perseverance? Curiosity and Perseverance are studying ancient habitable environments exposed on the surface of Mars, and both missions have found evidence that the basic ingredients that life needs to exist were present at the surface or near subsurface on Mars billions of years ago. InSight offered us an unprecedented view into the interior of Mars. What is the biggest unanswered question about Mars? Although we know now that Mars was a habitable planet in the past, the biggest unanswered question about Mars is whether it actually hosted life. Mars' surface. The planet's cold, thin atmosphere means liquid water likely cannot exist on the Martian surface for any appreciable length of time. Features called recurring slope lineae may have spurts of briny water flowing on the surface, but this evidence is disputed. Some scientists argue the hydrogen spotted from orbit in this region may instead indicate briny salts. This means that although this desert planet is just half the diameter of Earth, it has the same amount of dry land. The red planet is home to both the highest mountain and the deepest, longest valley in the solar system. Olympus Mons is roughly 17 miles, 27 kilometers, high, about 3 times as tall as Mount Everest. While the Valles Marineris system of valleys, named after the Mariner 9 probe that discovered it in 1971, reaches as deep as 6 miles, 10 kilometers, and runs east-west for roughly 2,500 miles, 4,000 kilometers. That's about 1/5 of the distance around Mars and close to the width of Australia. Scientists think the Valles Marineris formed mostly by rifting of the crust as it got stretched. Individual canyons within the system are as much as 60 miles, 100 kilometers, wide. The canyons merge in the central part of the Valles Marineris in a region as much as 370 miles, 600 kilometers, wide. Large channels emerging from the ends of some canyons and layered sediments within suggest that the canyons might once have been filled with liquid water. Mars also has the largest volcanoes in the solar system, Olympus Mons being one of them. The massive volcano, which is about 370 miles, 600 kilometers, in diameter, is wide enough to cover the state of New Mexico. Olympus Mons is a shield volcano, with slopes that rise gradually like those of Hawaiian volcanoes, and was created by eruptions of lava that flowed for long distances before solidifying. Mars also has many other kinds of volcanic landforms, from small, steep-sided cones to enormous plains coated in hardened lava. Some minor eruptions might still occur on the planet today. Channels, valleys and gullies are found all over Mars, and suggest that liquid water might have flowed across the planet's surface in recent times. Some channels can be 60 miles, 100 kilometers, wide and 1,200 miles, 2,000 kilometers, long. Water may still lie in cracks and pores in underground rock. A study by scientists in 2018 suggested that salty water below the Martian surface could hold a considerable amount of oxygen, which could support microbial life. However, the amount of oxygen depends on temperature and pressure. Temperature changes on Mars from time to time as the tilt of its rotation axis shifts. Many regions of Mars are flat, low-lying plains. The lowest of the northern plains are among the flattest, smoothest places in the solar system, potentially created by water that once flowed across the Martian surface. The northern hemisphere mostly lies at a lower elevation than the southern hemisphere, suggesting the crust may be thinner in the north than in the south. This difference between the north and south might be due to a very large impact shortly after the birth of Mars. The number of craters on Mars varies dramatically from place to place, depending on how old the surface is. Much of the surface of the southern hemisphere is extremely old, and so has many craters, including the planet's largest, 1,400-mile-wide, 2,300 kilometers, Hellas Planitia, while that of northern hemisphere is younger and so has fewer craters. Some volcanoes also have just a few craters, which suggests they erupted recently, with the resulting lava covering up any old craters. Some craters have unusual-looking deposits of debris around them resembling solidified mudflows, potentially indicating that the impactor hit underground water or ice. In 2018, the European Space Agency's Mars Express spacecraft detected what could be a slurry of water and grains underneath icy Planum Australe. Some reports describe it as a lake, but it's unclear how much regolith is inside the water. This body of water is said to be about 12.4 miles, 20 kilometers, across. Its underground location is reminiscent of similar underground lakes in Antarctica, which have been found to host microbes. Late in the year, Mars Express also spied a huge, icy zone in the red planet's Korolev crater. Mars moons. The two moons of Mars, Phobos and Deimos, were discovered by American astronomer Asaph Hall over the course of a week in 1877. Hall had almost given up his search for a moon of Mars, but his wife, Angelina, urged him on. He discovered Deimos the next night, and Phobos 6 days after that. He named the moons after the sons of the Greek war god Ares. Phobos means fear, while Deimos means rout. Both Phobos and Deimos are apparently made of carbon-rich rock mixed with ice and are covered in dust and loose rocks. They are tiny next to Earth's moon, and are irregularly shaped, since they lack enough gravity to pull themselves into a more circular form. The widest Phobos gets is about 17 miles, 27 kilometers, and the widest Deimos gets is roughly 9 miles, 15 kilometers. Earth's moon is 2,159 miles, or 3,475 kilometers, wide. Both Mars moons are pockmarked with craters from meteor impacts. The surface of Phobos also possesses an intricate pattern of grooves, which may be cracks that formed after the impact created the moon's largest crater, a hole about 6 miles, 10 kilometers, wide, or nearly half the width of Phobos. The two Martian satellites always show the same face to their parent planet, just as our moon does to Earth. Mars quick facts: size, composition and structure. Mars is 4,220 miles, 6,791 kilometers, in diameter. Far smaller than Earth, which is 7,926 miles, 12,756 kilometers, wide. The red planet is about 10% as massive as our home world, with a gravitational pull 38% as strong. A 100-pound person here on Earth would weigh just 38 pounds on Mars, but their mass would be the same on both planets. Atmospheric composition, by volume. According to NASA, the atmosphere of Mars is 95.32% carbon dioxide, 2.7% nitrogen, 1.6% argon, 0.13% oxygen and 0.08% carbon monoxide. That's with minor amounts of water, nitrogen oxide, neon, hydrogen, deuterium, oxygen, krypton and xenon. Mars climate. Mars is much colder than Earth, in large part due to its greater distance from the Sun. The average temperature is about -80 degrees Fahrenheit, -60 degrees Celsius, although it can vary from -195 F, -125 C, near the poles during the winter to as much as 70 F, 20 C, at midday near the equator. NASA's Mars Reconnaissance Orbiter found the first definitive detections of carbon dioxide snow clouds, making Mars the only body in the solar system known to host such unusual winter weather. The red planet also causes water ice snow to fall from the clouds. The dust storms on Mars are the largest in the solar system, capable of blanketing the entire red planet and lasting for months. One theory as to why dust storms can grow so big on Mars is because the airborne dust particles absorb sunlight, warming the Martian atmosphere in their vicinity. Warm pockets of air then flow toward colder regions, generating winds. Strong winds lift more dust off the ground, which, in turn, heats the atmosphere, raising more wind and kicking up more dust. These dust storms can pose serious risks to robots on the Martian surface. For example, NASA's Opportunity Mars rover died after being engulfed in a giant 2018 storm, which blocked sunlight from reaching the robot's solar panels for weeks at a time. Mars, orbit around the Sun. Mars lies farther from the Sun than Earth does, so the red planet has a longer year, 687 days compared to 365 for our home world. The two planets have similar day lengths, however. It takes about 24 hours and 40 minutes for Mars to complete one rotation around its axis, versus 24 hours for Earth. The axis of Mars, like Earth's, is tilted in relation to the Sun. This means that like Earth, the amount of sunlight falling on certain parts of the red planet can vary widely during the year, giving Mars seasons. However, the seasons that Mars experiences are more extreme than Earth's because the red planet's elliptical, oval-shaped orbit around the Sun is more elongated than that of any of the other major planets. When Mars is closest to the Sun, its southern hemisphere is tilted toward our star, giving the planet a short, warm summer, while the northern hemisphere experiences a short, cold winter. When Mars is farthest from the Sun, the northern hemisphere is tilted toward the Sun, giving it a long, mild summer, while the southern hemisphere experiences a long, cold winter. The tilt of the red planet's axis swings wildly over time because it's not stabilized by a large moon. This situation has led to different climates on the Martian surface throughout its history. A 2017 study suggests that the changing tilt also influenced the release of methane into Mars' atmosphere, causing temporary warming periods that allowed water to flow. Future human missions to Mars. Robots aren't the only ones getting a ticket to Mars. A workshop group of scientists from government agencies, academia and industry have determined that a NASA-led manned mission to Mars should be possible by the 2030s. In late 2017, the administration of President Donald Trump directed NASA to send people back to the Moon before going to Mars. NASA is working on this goal via a program called Artemis, which aims to establish a sustainable, long-term human presence on and around the Moon by the late 2020s. The lessons and skills learned from this lunar effort will help pave the way for putting boots on Mars, NASA officials have said. Robotic missions to the red planet have seen much success in the past few decades, but it remains a considerable challenge to get people to Mars. With current rocket technology, it would take at least 6 months for people to travel to Mars. Red planet explorers would therefore be exposed for long stretches to deep space radiation and to microgravity, which has devastating effects on the human body. Performing activities in the moderate gravity on Mars could prove extremely difficult after many months in microgravity. Research into the effects of microgravity continues on the International Space Station. NASA isn't the only entity with crewed Mars aspirations. Other nations, including China and Russia, have also announced their goals for sending humans to the red planet. And Elon Musk, the founder and CEO of SpaceX, has long stressed that he established the company back in 2002 primarily to help humanity settle the red planet. SpaceX is currently developing and testing a fully reusable deep space transportation system called Starship, which Musk believes is the breakthrough needed to get people to Mars at long last. For more videos like this, please subscribe, like and share our channel.